Welcome to Pretty Good House, and this is a webinar series that we're starting to help give more information on the topic of Pretty Good House and how to build a better house. So I'm going to introduce you to the people who are on the webinar today, and if you're interested in participating in future webinars, we will add information here to the show notes so that you can participate in future webinars. But first, we have Mike Maines, who you may have read quite a bit about. Mike is a designer here in Maine and one of the founding members of the Pretty Good House. So introduce yourself, Mike.
Hi, Emily. Thanks for having us on today. Yeah, I'm a residential designer, former builder, and I also do some building science consulting and try to do pretty good houses whenever I can.
Great. Then we have Dan Kolbert. He is also a builder here in Maine and one of the founding members of the Pretty Good House. And actually, it was Dan that sort of said while he was building, I just want to build a pretty darn good house. So go ahead and introduce yourself, Dan.
I didn't say pretty darn good house. Yes, I'm a builder in Portland. I've been the moderator of our local building science discussion group for the last decade. And I'm an occasional writer for GBA and Journal of Light Construction.
Great, thanks Dan for joining us. Then we have Josh. Josh is joining us from Vermont. Josh is also a builder, so go ahead, give us a little brief on you, Josh.
Well, I'm Josh Engle. I live in Brattleboro, Vermont, and build in the area. One of the specialties, or we build energy efficient houses. I'm not sure if I've ever built a pretty good house, but all the houses I've built are pretty good. We just recently, we're still in construction and building a passive house. And mostly we were there anyway, and we just decided to get the certification, but I'm not sure if it's actually worth it other than to say, well, I built one of these things. So I'm basically on board with the whole concept of the pretty good house, and here I am.
Great, thanks, Josh. We have Bob. Bob Swinburne is an architect in Vermont and also another pretty good house guru. Him and I call us groupies, but Bob's helped really put together the website here for Pretty Good House and has been instrumental in this next phase. So go ahead, tell us a little bit more about yourself, Bob.
Sure. I'm an architect in Vermont, and I've been doing, well, essentially pretty good houses for 15 or 20 years. And I originally cut my teeth working for the firm that Josh now owns as a carpenter, but I was also designing houses and building them at the same time. And then I moved on to become just an architect, really focus on that. And I've worked quite a bit with Josh's crew. And Josh, you have done pretty good houses. I can list a few. And so, yep, that's me.
Bob, thanks for bringing the funny today too. I really like the post-it note. Hello, my name is Bob.
Is that mirror image or is that correct in your screen? I can't.
It is correct in my screen, okay. So that's great. Then we have Corinne with Tiny Homes of Maine. We definitely wanted to invite Corinne on for this economics because I know that she definitely reaches a different market where people are, saying, hey, and we'll talk about this as we jump into it, but building a house is expensive. Where can I start? So Corinne, tell us a little bit more about you.
Sure. I'm the owner of Tiny Homes of Maine. We design and build efficient tiny homes, mostly built on wheels, and we build them in a facility in Holton, Maine. So we have a few standard designs, and then we will design any custom space for anyone. And yeah, that's it.
Great, thanks for joining us. We lost Ashley for a minute. We'll have her pop back on when we get there. So in the meantime, I just want to give a brief introduction to what is Pretty Good House. Pretty Good House is an introduction. What we'd like to do with this webinar series is really talk about the 12 guideposts of the Pretty Good House. And this first one here in January is going to be on economics. But I thought maybe it was worth talking a little bit about what the Pretty Good House is and why we started this and where we're going with it. So the Pretty Good House, or the Pretty Darn Good House, or not exactly what Dan said, practical, low carbon, high performance construction. And why we do this, for a lot of years, those of us in high performance were thinking about that 30-year goal and building things that were more efficient and used less operational energy. But if you've been kind of following anything in the news and climate change and everything else, we actually need to shift our focus and think more about carbon emissions. And this is a nice little chart here that talks about building operations and building materials and how much carbon is going in from day one, not just what we're going to use over the next 30 years. And operational carbon emissions is, everything: heating, cooling, ventilation, appliances, plug loads, whatever is in your building after it's built. But embodied carbon is, what did it take to get it out of the ground, process it, get it to your site, and the life cycle of that material. And so we need to talk about embodied carbon, because this chart here shows you that embodied carbon is about the same, and operational carbon is going to go up, and the next 10 years are going to make a huge impact. If we don't start thinking about all of this, then pretty soon it's going to be too late to worry about all of this. So by our 2039, you can see that they are the same. So the next 10 years, we need to make a huge dent so this line goes down. That's my simple explanation there. I'll let other people weigh in on that. But for the next 40 years, the world is projected to add, that is a big number, square feet of buildings, doubling the existing building stock. So that's equivalent to building New York City every 34 days for the next 40 years. So that gives you an equivalent of what we're going to build to keep up with our population and new construction going forward. And that is where the Pretty Good House then also started to think about not just building a house that uses less and has less square footage, but also starts to think about the low carbon edition. How do we have as much low carbon materials? And we started the prettygoodhouse.org or the prettygoodhouse.com to get to the website. And we'll keep this up and put it in the show notes, but you can get more information on the overall Pretty Good House and the guideposts to how to build a pretty good house. So we'll start with some key elements. What should include in your Pretty Good House is to try to build smaller. A lot of us think that square footage is just a number. So let's get out of the numbers game. We need renewable energies or ready for renewable energy, simple and durable, wood and other renewable materials or carbon negative materials, air source heat pumps, invest in the envelope, good orientation, good windows, good doors, keep it simple and safe, good air quality, understanding owner-proof systems. We don't want to make it more complicated for people, and be part of a sustainable community. So using local materials, local labor, and access to community solar, community jobs, and minimize driving infrastructure costs. What you should be a part of, whenever possible, embodied carbon already sequestered. So renovate, 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 aim for current or international code performance, because even that is significantly better than when your existing structure maybe was built in the 1800s. And apply your money saved towards PV. And there are a lot of economic challenges, and I'm not sure if we'll have a chance really to cover economics on new construction versus renovation projects in this webinar. But things that we should avoid with Pretty Good House, one-hit wonders in the middle of the woods. As great as that foam-laden passive house on 10 acres in the middle of the woods is that as good as really concentrating on some of the larger infrastructure that we have. Minimize concrete, minimize foam and XPS, combustion appliances, and toxic and unhealthy materials. So anyway, this is a really quick, broad overview of what a lot of these things are. And it may seem simple, but it's complicated, and it's complicated assembly. And next month in February, we're going to talk about team and putting that all together. And the most important thing economically maybe that you can do is team. So think about that as you move forward. Here's the roadmap. So if you go to Pretty Good House, this is a visual display of all the things that we think about. And what I love most about this visual display is that it's complicated. It shows you that it's complicated, and we're trying to offer some simplifications on how to get to a pretty good house. So economics. This is what everybody wants to talk about. How to balance expenditures versus the gains. What's the return on investment? What are the first costs versus lifetime costs of a structure, and renovations versus new construction? So this is the topic for today's webinar. And so today you're actually talking to the people who started Pretty Good House are all in the cold climate. And so we have a lot of cold climate references. The goal, hopefully, with Pretty Good House is to also get some professionals to come on and talk about their own climate zones. But how you handle a pretty good house and how you handle it economically is going to be different depending on what climate zone you're actually in. So that's an important task to understand. So hot, dry, moist, there are 7 climate zones in the United States. It's completely different how you treat a structure depending on where you build it. And we have a couple of great houses that are stunning examples. This one was in a fine home building of Pretty Good House. This is a house that I designed in Cumberland as a pretty good house. It's net zero ready. It's orientation. We minimized the square footage for a 4-person house to under 1,700 square feet. Lots of great things on it. This house is a house by Bob, Vermont Simple Home. I actually think that this one is built in Maine, and so, or was originally designed and built in Maine. But really simple aesthetics and how that can be economic. And maybe Bob will touch more on this project on this house by Mike Baines, which is here in Maine as well, and how they can be completely different and have different aspects on how to achieve a pretty good house. So prettygoodhouse.org. We can learn more information on that. And let's just jump into the discussion on economics.
I am from Maine originally, but I am in Vermont right now. So in addressing economics, I spent some time digging around on various websites and reading through all the comment sections. And the big takeaway I realized is that, well, Pretty Good House is a subset of green building. And so if you find out what people are asking about green building or what they're thinking about green building, I think there's a lot of misconception out there that green building means more expensive, and it's this added on thing. And, you know, I'd love to build, you know, a green home, but I can't afford to. So I think, you know, what we need to do with Pretty Good House is really address that and address the misconceptions. And a lot of those misconceptions come from architects, they come from builders, and they come from the media. And so I think what we have to really try to do with Pretty Good House is to cut through the crap and really simplify that discussion, because it really is a fairly simple discussion. And so I think, I mean, that's the main point I wanted to bring in today, is just let's address some of these myths and misconceptions.
I think that's a great point. And Josh, I know you talked a little bit about this when we first were getting on the webinar before we started the recording, about how from your experience, it's not that much different to improve the insulation package or that much more expensive. And so I don't know if you want to talk a little bit about your experience in just doing things that are not really that much more expensive to do. I know from my viewpoint, and this is something that architects knew way back in ancient Rome, was if you orient the house the right direction, that can be a huge savings. And from my perspective as an architect, that generally doesn't cost any more. But maybe you can talk about materials or things from building that you find aren't really more expensive.
Yeah, I mean, last year we built a house. It was about 1,600 square feet, 2-story. And after writing up the estimate, I just, we basically have a big spreadsheet that's all the tasks lined up with materials and subcontractors and everything. And I went through and pulled out everything that we added to the building above code minimum, and to bring it up to a pretty good standard, and I would say a very good standard actually. And the cost increase was 2% of the budget. It's like I couldn't believe it. And we could probably bump that up to 3% if we really tried. But really, 2 or 3% isn't much. It's really almost, our margin of error was way bigger than that. So I suddenly realized we don't really, we used to harp on, oh yeah, you need a well-insulated house, you need a well-air-sealed house. We explain all those things to our clients, but we don't even use it as marketing anymore, because I've realized it just ends up being a discussion about how thick are your walls going to be. Do you really need air sealing? Whereas really we want to emphasize that we're building you a really good house. We're not building you a crap house. It's going to be well built. It's going to stand the test of time. And well, part of that is going to be, it's going to use very little energy. And that's just a part of it. We're not trying to sell the energy efficiency of it. It's just part of the package. A lot of that really has to do with, the air sealing is, it's just a matter of practice. We wrap the building in some kind of layer of something anyway, which we used to call Typar. We can use a different material, it doesn't cost that much more. And then we tape it, and we just have to make sure to get a few details right. I'm not going to go into all those details, but as long as you've done it a couple times and you know what to do ahead of time, it's not difficult. And in terms of bringing the R value up, once again, it's just practice and a little bit more materials, a little bit more work, but it's not difficult, basically. What it takes is practice and the willingness to experiment, try it. And luckily we have a crew that's willing to try it. A lot of them are willing to work on the details, figure the details out themselves. But the takeaway really is it's not that much more expensive. So we don't talk about the costs. We just say it's part of the building, and don't worry, it's not expensive. It's a misconception. So that's basically it.
So I'll jump back in. So, yeah, what was I going to say? So the misconception thing, and I get that, from builders who've never done it before, because they know how to do things. They've always done it this way. And I've had builders simply just throw out an inordinately high number for bringing a house up to, just a little bit of a higher standard, simply because they don't want to be bothered. And I think that, the general public, anybody considering building a new house is going to run into that attitude more often than your attitude. And so I guess the question is, how do we, hopefully people have found pretty good house and they're starting to ask these questions. They're here, maybe they're watching this. And so, what tools can we give them to go back to, their own location, their own, the builders that they have to choose from? What tools can we give them to start that conversation and not quickly get, washed aside and fed up with it and frustrated?
I think I'd like to weigh in on that too. As an architect, I agree with everything you say, Bob, but I'm also a HERS rater. And as a HERS rater, we've done energy efficient mortgages, and we've done energy models where we also take into account what it's going to save you every year then to live in that house. And I feel like that's a conversation that we don't have often enough, where even if it's that extra 1%, 2%, 3% upfront additional cost, what is it going to cost you then to continue to live in that house? You guys are kind of in a rural area of Vermont. A lot of us are in rural areas of Maine, and the cost of getting the fuel that you need, or the electricity rate is higher in some parts of the country, or even a lot of New England still heats with fuel oil, which is just, I mean, it's crazy. Let's get off that. Let's move away from that. But there's no access to even gas appliances that are more efficient. But we don't talk to people when they buy a house or renovate a house or build a house about what it's going to cost to then live in it afterwards. And so as a HERS rater and providing energy efficient mortgages, we can say, hey, you can spend an extra $10,000 on insulation. It'll pay for itself in 1 year, 2 years, because you're saving $2,000 a year. It takes 5 years to pay off. And so since we're talking about economics today, I think it's a valuable point that, the fact that people just say, oh, well, it just costs more to do that, is that we need to have the conversation of, well, what does it cost then to live in it? So, and that's a really big factor, is we want to be talking about carbon and carbon materials and the things that are going into our house, but we also want to talk about what it costs then to live in it afterwards. So,
yeah, the cost of ownership is something we see a lot in multifamily housing, where financing for multifamily housing really takes into account not just the cost of construction, but the cost of ownership for various different lengths of time. I have heard that in Europe and other parts of the world, the mortgage industry operates more that way. Here in the United States, very little of the mortgage industry operates that way. And so I think a lot of people run into that roadblock where, it might cost $2,000 a month overall cost to live in the pretty good house versus a code minimum house, which costs less to build, but more to maintain, not just heat and cool, but actually maintain qualitative materials and so forth. And so their out-of-pocket monthly costs from month one, forget ROI, might be $200 or $300 a month more. So we need to address potential changes in the banking industry.
Yeah, well, and speaking of banking, once you reduce your monthly operating costs, $300 or even $100 a month in extra energy savings, if you apply that towards a typical 30-year mortgage, the amount of money you can borrow is pretty staggering. It'll easily cover any energy improvement upgrades you'd want to consider if your goal is to keep your monthly expenditures the same. And on a related note, I think to go back to what Josh was saying about the added 2 to 3% in costs, I mean, sort of a core tenet, maybe the core tenet of the Pretty Good House approach, is that there are other excellent programs out there, but that often they often either don't go far enough to make sense, or they go beyond what makes financial sense. So in a Pretty Good House, basically keep making improvements until it stops making financial sense. And what that means will depend on where you are and what house you're building, but often it means just I know in our climate zone, put in good windows, get enough insulation and air sealing that you can heat your whole house with 1 or 2 mini splits that don't have to work very hard. So your total annual heating and cooling costs might be something like $1,000, and you can generate your own energy on site with PV panels, as opposed to $2,500 of heating oil and the lack of comfort and everything else that may cost roughly the same on the first day, or maybe cost a little less on the first day.
I think one of the other tenets of Pretty Good House is, reducing square footage. So I actually would love that if Corinne wants to weigh in. I get a lot of bad flack on tiny houses, but in some ways, economically, that might be a solution to some of the housing in the U.S. And I know that the way that you build them and over the road and how they work is, it may not meet the traditional standards of what is required for a stick-built site house, but that it's tiny and it's super efficient and it uses very little to operate. And so that might be, a solution to, economics as well.
Yeah, it's funny being in the tiny home industry, because there's a whole new set of misconceptions. People are used to dealing in square footages, So when someone wants a tiny house, they're asking for 600 to 1,000 square feet. And, our tiny homes are 200 square feet. So I kind of try to shift it to volume of measurement. But we have traditional, it's a stick-built house built on a steel chassis. We use a zip system, Rockwell, Anderson windows. So it's very efficient. But the misconception on our side is that it's gonna be proportionally cheaper to build this tiny house because it's tiny, when what Josh was mentioning, the cost of materials, the cost of labor, contractors, those are all the same. The footprint's tinier and it's less time. It takes 90 days or so or less to build a typical tiny house. But when I talk to the homeowner, what really excites them is, $50 maximum for heat and electricity a month. And they want to know, is that green certified? Is this a net zero home? And what are your qualifications and all of that? And it's just where green and techniques or, so it is hard for me to try to convey all of those ways of thinking from a traditional house, just tinier, if that makes sense.
I think that's actually an excellent point, and really follows up along with what Josh said, which is that, when you're building a tiny home, it's not necessarily cheaper per square foot to build a tiny home. You just only have 200 square feet. We get that a lot in architecture and the planning phase, which is someone will say, well, I only want to build 1,000 square feet. Why is it so expensive? And I say, you still have a kitchen, you still have a bathroom, you still have all these things that are expensive within a house. And oftentimes the insulation and the air sealing, which are so critically important to, the performance of the house, isn't the part that's driving the expense of the overall house, but it's definitely what's driving the operational costs. So I don't know, Dan, if you want to weigh in on some of that. I know you've built Passive House, you've built Pretty Good House, you've built a lot of those things. Do you get a lot of pushback from actually all the builders, Josh, Dan, Mike? One of the biggest challenges for me as the architect is, someone will say, well, let's swap out this type of insulation or something. And I want to say, you can change whatever you want within the inside of the building envelope, and the building envelope is mine. But I don't know, from an economic standpoint, whenever people start talking value engineering from a designer standpoint, is they want to start taking out the things they can't see, but that have such a big impact in lieu of the things that they can see and the things that they like to see, like windows or a pretty kitchen or nice flooring.
Yeah, we had that as in our building science discussion group years ago. We had a great discussion about this topic, about how to keep those, how to keep your house energy efficient through the design process and make sure it doesn't get lost in the value engineering. And one of the ideas was basically to say, the shell, as you just said, the shell is ours, right? The shell is the builders, or the shell is the designers, or whatever. And we're going to present you with a package that works as a unit, and you can't mess with it. So yeah, and I would also, on the economic front, the other thing I was just thinking about was, we need to talk about the time frame for a lot of these things too, right? When you're talking about decisions, are we talking about a 5-year, or what's the length? How long are we expecting to live in this house? How long do we hope the house will last? Are these decisions weighed out over 5 years, 10 years, 50 years, et cetera? It comes back to some of those, the whole carbon accounting, which I'm sure we'll get into more. But, the idea of what's the economic payback? What's the environmental payback? Are there things that will cost more upfront but will last a lot longer, like say metal roofing? questions like that.
I think talking about the carbon and environmental impact, I definitely brought that up on the podcast. It's an overarching goal of the Pretty Good House, but I think it really factors into economics here too, is that we aren't necessarily talking dollars and cents with economics, as was reiterated in the slideshow that we went through very briefly. Which is, what is the economics of what we're doing to our environment, and how is that going to have an impact, and carbon negative materials that we might use. And so some of the questions that come up, and maybe we can touch on it a little bit here, is, do I build new, or do I renovate an existing structure? And at what point are you doing a gut rehab on an existing structure that's actually using more carbon material than you would have if you would have just built new? And I don't know if anyone wants to weigh in a little bit on that as far as renovations go, is we oftentimes find that renovations are more expensive.
Yeah, absolutely. And that's a pretty standard rule, with or without energy efficiency. I mean, on a square foot basis, renovation is always, well, not always, but certainly typically much more expensive than new construction.
Just to go back to Corinne's, and she's operating at the smallest end of the scale, and I in trying to steer people away from that cost per square foot conversation, I like to tell people there's an inverse ratio between size and cost. So the smaller you get, the higher the cost per square foot. The larger you get, the lower the cost per square foot. And I think, sometimes we're always trying to steer people away from square foot. If you can steer them more towards simplicity of form, I think there are much bigger savings to be had there. And I think that really ties into the Pretty Good House approach of really developing a whole process of designing and building a home, as opposed to a more traditional approach of, choosing a plan, choosing a builder, getting it built. That whole integrated process has a lot of inherent cost savings in it. Not just the whole, the quality aspect of it, the energy efficiency aspect of it, but just you can really control costs and reduce costs. And I think that by following this approach, very often you can spend less money. If upfront costs are the issue, I think there's huge cost savings to be had in the process.
Yeah, I don't know, Ashley, if you want to weigh in from the architect's perspective, but you and Bob and I and Mike, as designers on the design front, often building a simpler structure and spending the time in design could make a much more cost-effective and much greener house than you can get otherwise. But do you find other pushback from your clients as a newer architect, kind of really getting into this building science? Are you finding economic questions, both whether the client doesn't want to spend it in the design phase, or just otherwise kind of going into the initial phase where you want to try to simplify and get people away from that, square footage, or I need to have this huge house or big space?
Yeah, for sure. So, hi everyone, I'm Ashley. I'm an architect up near Sugarloaf in Maine, in western Maine, in the middle of nowhere. But yeah, so I work on projects in Maine, but also in California and Texas and all over the place, and specifically with one builder in Texas who is a great guy and he has the best intentions, but I've been trying to slowly get him into Pretty Good House thinking, and the resistance is unbelievable. Not just from him, because it definitely comes from him, but also from the client, and the culture down there is different than it is up here also. But even things as simple as, let's not put the furnace in the attic, it's a hard sell. So I'm we're getting to the point where he is accepting smaller floor plans, because no matter what, that's cheaper for him. So now I'm trying to, we're going smaller, and now I'm going to try and get him into the better assemblies and systems. So yeah, there's a lot of pushback. I think that a smaller floor plan is the easiest to sell for sure. Less square footage is the easiest to sell. I mean, once you get down to the tiny home level, it's a different ball game altogether. But and then around here, I am just getting into sustainable design, so it's I don't have a whole lot of clients yet that are coming to me specifically for that. So it's really just trying to persuade existing clients to do this because it's better for them. And that's part of the reason I'm really excited about this, so I can understand. I mean, money speaks. So if I can tell them, if we reduce the square footage and take out some corners and some valleys in the roof and, put in better, more efficient systems, and then we'll save you a lot of money in the long run. I'm starting to get there, but yeah, I'm excited for some numbers and maybe examples at some point, or trying to find those myself and sell it that way. It's challenging.
I think that's the point of the Pretty Good House and getting people to that level is, how do we provide a landing place that kind of helps you get to Pretty Good House? And definitely one of the things that comes across is, like Josh mentioned, Bob mentioned, and I've mentioned, and probably a lot of the people on here, is you sort of just start doing things as a rule of thumb, and then people stop asking you about it. And so, and I don't want to say that you shouldn't know, but those technical aspects are part of the reasons of how we can get you to, to a really efficient or low carbon house, is to, create these simpler structures, or maybe they're smaller structures, or better built, or with better materials. And that's one way to, to really control the economics from a design standpoint.
I do have a question about that. How do you, I assume a few of the designers on here are working on projects where that are remote, where you can't do a lot of construction admin. You can't actually observe what's being built. Is there a way that you can, are you checking to see if what you're speccing is being value engineered out after you're out of the picture, or how do you guys handle that?
I'll go. I'm sort of trying to avoid doing the remote stuff more and more, but it is, it does come up, and as architects we have a much greater range that we can work in, so we have to adjust what we do. And part of how I handle that is a thorough vetting of the builder, not just the client, but to find out what their comfort level is, what they're looking at, what their enthusiasm level is. That is key. That's everything. Because if they know nothing but they have enthusiasm, then I can fill them up really quick. And part of the purpose of doing this whole Pretty Good House website and really pushing this concept forward is so that we all have a good, clean, one-stop resource that we can use to assist us in that conversation.
That brings back, and we'll touch on this a little bit more at the end as it leads into team. But one of the conversations that a few of us had before the start of the webinar was putting together a really integrated design process, and how design build works, how working as a collaborative team so that the builder is brought on during design. And I don't know if Dan wants to expound on it, because he wrote this article about 9 years ago, but how putting projects out to bid is actually not a cost-effective way to really get a great project. And so since we're talking about economics, maybe we'll talk a little bit about design bid build versus an integrated design process.
Yeah, I think that there's a few issues. One is, what are the incentives, right? If you are just designing a project and then putting it out to bid, the incentive is always for the builder to come in as low as possible at the initial bid and not bring to the attention of the client or the architect all the things that they see that are missing or that are going to be difficult, potential change orders down the road. If they know they're bidding against somebody else, they want to make sure that their initial price is very low. The other thing is that it's just not a useful, if you build a team, you can use the expertise of the builder. If the builder knows that he or she, unless something goes horribly wrong in the design process, is going to be the builder, there's a lot of incentive there to say, all right, this is how we build this more efficiently. This is how we save you some money. It could be something as simple as just, we've got a fork in the road in the design process. We're thinking about this or this, and the builder can easily say, I can't put a number on it, but I can tell you that, A is cheaper than B. So all things being equal, they might choose that. It's also, I think it's also a great way for the client to find out, do they want to work with this person? It's sort of a way to date before you get married.
Yes, I'm totally backing that up. What we're doing more and more is, as an architect, I encourage a pre-construction agreement where we get to bring in the builder at the start of design, invest them in the design every bit as much as the construction, get them enthusiastic about it, really, and get their input, not just on the construction, but also on the design, because I think we tend to separate ourselves so much. So anything that can be done to bring us, because we are, we're working on the same team, the same project, we have the same goals, we have, and we have our own strengths. Yeah, that in terms of, Ashley, to address how to get that higher level of conversation and control, it is so much about starting that conversation really early. And with the pre-construction agreement, I get the builder not working for free, but giving advice, helping with pricing, helping with detailing. And it is sort of like a first pass. And, we could potentially let that builder go if it's really not working out and there's not a lot of investment there.
I just wanted to add on to that. We have a process that works out pretty well, such that we are the designer and builder, and we meet face to face with the client. So we kind of have that, dating period. So how our process works, which is kind of neat, is if you're serious about custom tiny home fee, and that's a consultation, and we design your tiny house based on your feedback. So you get a virtual tour of a 3D model in Revit. And we're getting to know this person too, because we've said no to a few clients, just from lessons learned, and they get to know us, and then it's nice to get to know people before you jump in on a project, even though it's tiny. It's, for some people, that's still a lot of money, when you're talking about anywhere from $70,000 to even $100,000 for a tiny home. So it does work out really well to have that continuity, and getting to know people, and the benefit of being the designer and the builder. You can make those decisions on the fly, which has been nice.
I want to also add back to the same subject, also what Bob was saying about a lot of times the first thing clients want to know from me is, how much is it going to cost? And that always ends up odd, because I say, well, what is it? First, you have to define what it is. You don't have a design yet. I can't tell you what it's going to cost if it's not designed. And even if it were designed, it's going to take me 40 hours to price this whole thing. But they don't want to have me spend 40 hours and God knows how many thousands designing it, only to find out that it's cost twice as much as they expected.
You have to have that conversation. I mean, I think what people watching this discussion could come away with is that it's not, there's a better way of doing things. There's different ways of doing things. It's not, you don't go to a builder or an architect and they tell you how to do things. There's, we're hopefully giving people some ammunition to think about the process. I mean, hopefully by the time, if they know about, or if they've stumbled across Pretty Good House and they've made it this far, they have some interest and they're interested in hearing what, we have to say. This is almost sort of a behind the scenes view of how we work, how we operate, how we think about things. So I think that there's some usefulness along those lines.
And I mean, basically it's a feasibility test early on. Is this project going to fly at all? Or do you need to completely start from scratch? And so a lot of times before, architect is involved, before any kind of design is involved, we're figuring out, what's the ballpark price, which is always dangerous. But a lot of times it comes in a lot higher than people expect. So I feel like a lot of times that's already a place where me from the builder perspective, where you know, if they come with an architect already in mind, that's already designed something, it's already a failure.
So a better way to look at it is when a client comes to you or me, we find out, okay, how much do you have to spend, and work backwards from there. And the initial feasibility, very often we can tell them right up front, yes or no.
Yeah.
And that happens, you know, that certainly happens a lot. It happens several times a year. And where you just have to break it to them right up front, and maybe they go find somebody who will tell them something else, and whether it turns out true or not, it's, you know, that's a whole nother story. But sort of working backwards, the very, you know, within 5 minutes you can say, yes, this may be possible, no,
Yeah.
it's not, and then just work it out from that direction.
Yeah, usually I try to, before I ever commit to any kind of financial figures, I try to get at least 2 meetings in so that they learn to trust me. Just show up. Here's Josh. Oh, it's going to cost way too much. You know, so then I get my reputation of being an expensive builder, and someone else gets their reputation for being cheap and dishonest.
My clever line is, it's easier to design to a budget than budget to a design.
Yeah.
Oh,
Yeah.
we can use that. We can use that.
That is a great line right there. That might be a nice one-liner for a pretty good house. So, Mike, you wanted to weigh in, maybe as far back as what Corinne was saying.
Well, I think it's more in response to Ashley's question as to how do you convince people to do this? I mean, it's great when you have clients who trust you, or if you're working with a builder like Dan, who's already on board with these you know, more energy efficient enclosures. But I have a lot of clients who want to use builders that I haven't worked with before, which is always an uphill battle. Or my clients want good, but not necessarily pretty good. And so what I've found works really well for me, although the pretty good house, you know, sort of includes some prescriptive standards, I found that doing some basic energy modeling really helps people make an informed decision. So I use BOPT, which is a free download from the Department of Energy. And, you know, it's not perfect, but it will tell you, you know, if your inputs are accurate, it will tell you within 10 or 20% how much energy you'll use over the course of a year with all kinds of variables. So I'll do, once we have a schematic design, like once we know roughly what a house is that my clients would accept, I'll do an energy model that shows that house built at code minimum. And then I'll change one parameter. I'll say, okay, what's it look like with, you know, so code minimum here is, say, R20 walls. I'll show an option with R30 walls, and then R40 walls. I'll do the same for roofs and equipment and lots of other variables. And I'll apply an estimate of what that upcharge would be. Fortunately, I have some idea of what things cost, so I can be somewhat accurate. And then I just get I put together a printout of, here's the return on investment to go up to an R30 wall. Here's the return on investment to go to an R40 wall. And I find most people, once they see it in that sort of black and white terms, it's pretty hard to turn down essentially a guaranteed 10% return on investment. I mean, that's better than most people do in the stock market. You know, maybe a 5% return is still decent because it's pretty much guaranteed. And, you know, considering energy costs, it will probably improve over time. And you know, lower returns, you know, things like going from double glazed to triple glazed windows may only net you a 2% or something return on investment. So not a very good payback, but you can then look at it, then that sort of, by isolating those things you can look at, okay, but it's this much better for the environment. It reduces carbon emissions by this much, or it improves the comfort quotient by this much. But it sort of knocks out of the equation, like, why are we doing double stud walls? It's like, well, because double stud walls make financial sense up to this point.
I think that's a great point. As a HERS rater, I do energy models on all of my projects so that I have a really good idea of where it goes. I use Ecotrope as part of it for HERS rating, so that you can get that, you know, prove you made a zero energy house by the sliding scale. If a code built house is 100 and zero energy house is 0, you know, where do you fall on the scale? Which is something that's, you know, fairly easy for people to kind of understand with economics. And I agree that showing the energy model often gives them a way to evaluate decisions. And then we also talk about the fact that windows are expensive. They very rarely pay for themselves. And so again, switching from that double pane to triple pane isn't always the right option. But if we can minimize the number of windows that we have, I like to say that every house has an ugly side. Let's make that side the north side of the house. Let's just eliminate as many windows as we can. We'll put our services and our utilities on the north side. Like, nobody wants to look at their compressor for the heat pump. Like, let's just hide that over there. Then maybe we can say, all right, we cut out 3 or 4 windows. We can afford to spend the extra money on this large window in the living room that's triple glazed that you're going to sit next to every year. Because I think one of the most interesting discussions I had was with a real estate agent who built a really beautiful $1 million house, and they lived in it for a year, and it was cold and it was horrible, and the windows faced the wrong direction. They must have faced north. They had a glass front all in the north. And they sold that house. It was beautiful, had granite kitchens, probably had a $40,000 kitchen in it, and they sold that house because it was really uncomfortable to live in it. And so when we're talking economics, it's not just the economics of what it costs to build, but the economics of, how does it feel to live in that space? If we're Maine has some of the oldest housing stock in the country, and it's still standing, and I won't say that it's all in great shape, because obviously it's not, but if we're trying to build more durable homes and the economics of doing that, we want people to stay in them. We don't want them to turn around and sell it the next year because for some reason it was uncomfortable to live in it.
Mike said something that got my brain spinning. We had talked about doing parallel case studies before, pretty good house next to code minimum. And, it would be really cool if we could do that with a series of slider bars, like the U value for the window, and just have it immediately react to, this is way beyond my programming capabilities, but immediately react to a dollar amount or something per month or per year. That would be super useful as a sales tool.
Sort of like an a la carte menu. Like, here's your house. Here's the Good House Guild. Here's the Vermont Simple Home 4, and triple pane windows, double pane windows.
Just to start with a real basic, square box, 1212 roof, 1,800 square feet or something like that. Run the numbers on it for a particular zone, and so that could be a really useful discussion tool. From there, you discuss what's your zone. What does that really mean? Are you thinking a larger house than this, a smaller house than this? And it's the type of thing you could even run through with somebody via a Zoom or a Skype meeting, and they could have it up on their screen, and you would say, okay, now let's look at what the difference in this model if we go from double glazed windows to triple glazed windows. And so that would become a really good conversational tool to really educate on that initial level, not just clients, but builders and architects. That could be really useful. I'll get right on it.
I guess I have something to say in that vein also, is that, as an architect, I don't know the prices of construction. I don't know what things cost to build. I have some idea what's more expensive than other things, but I think it might be really helpful to partner with a local architect, even if the client ends up not working with them, just to have them do some consulting in the beginning as far as the cost balance of what is the ROI going to be. I mean, Mike, that sounds like a fantastic process, and I would love to do that. I just need the numbers on the other end of how much these extra wall assemblies are going to cost. So I might try and look around for someone who would be willing to just work on it on a consulting basis to help me give the client those answers, because it seems like there's no one answer. There's not, your PGH house is going to cost a quarter, 50% more than a code built house, but you're going to get your ROI in 10 years. There's no numbers like that. It depends, on the house. So I think it might be really handy to partner with someone on that. Anyone know anyone?
We all know Mike.
Yeah.
He knows everything.
Right, good point.
I think that you're really correct, though, from the architect's perspective. Is I don't buy sheetrock, so I don't know when sheetrock goes up 20%. I mean, we're moving towards the model where we have a really integrated design process, and I'm actually on site with my contractors a little bit more, bringing them on during design phase, so they're actually doing cost estimating during the design phase. So we're working working through that. And again, I think that goes back to Corinne's idea of design build in-house, or the idea of a design build integrated process where that contractor is also involved, because I've often talked in the past about cost estimating, and it would be great to get away from the, like Dan said, to budget to a design versus to design to a budget. It would be to have, cost estimator available. But if you don't have a specific builder in mind, like, Josh and Dan have said, they've got processes that they've worked out with their individual guys that they know that some things are going to be more cost effective way for them to build it, just because they've kind of worked out a process. And from the architect's perspective, if you gave it to 6 people during a bid process, they'd all build it a different way. So, getting a cost estimator to look at something during the process may not be helpful if your builder that you then select isn't going to build it that way. In Vermont, you guys seem to be really hands-on, really experimental, willing to try a lot of things. In Maine, I find not quite as much experiment, a little bit more like, okay, I'll accept your idea if it's not that different from what I'm already doing. From a cost perspective there, to what they might be willing to do, and what they bring to the table. And it's totally different with the 5 or 6 different builders that I'm working with right now. I've got one guy that only does board sheathing, which I hear they do all the time in Vermont, but that's not too common here for us. And they say it's cheaper for them all day long to do it that way. And I mentioned that to another builder, and they're like, we'll never do that. So, so I think that's a really valid point to bring up as part of the design build process is a lot of times people will approach an architect to design them a high performance home and expect that they know the costs of everything. And people will say, well, I have this amount. In the very beginning, without a design, nobody can budget that. And so you throw out a cost per square foot, which we all know cost per square foot is like the worst possible way to budget for a project, because in my world, I like to use car analogies. So you could be a Ferrari or you could be a Chevy Volt, and I don't know where you are on your design selections. And I could say a double stud wall should cost you in this range all day long, but then what you do with the rest of it is really different. So I think in order to build green and to get, and I don't even want to use the word green because that word has been totally taken over by the market for whatever they want, but to build a high performance house or to do better with the economics of a house is, I think we need to all be moving towards this integrated design process. And I think that that's really the only way to really have an impact on the cost of building better. That's my personal opinion. Other people can weigh in on that.
I'd like to follow up actually with a question. So we have a standardized workflow and implement lean manufacturing similar to a car factory. So, what do you guys' take on standardized building in a controlled atmosphere, call it prefab, modular, manufactured housing, and implementing this way and still being able to customize? That way you're not so dependent on finding a builder. Anyone?
I've spent quite a lot of time thinking about how to make things ahead of time, from the whole house to small assemblies. Most of the houses I build are, well, all of them are custom houses. No one of them is the same. There are a lot of companies around here who will build a prefab house, high performance, nice features, prefabricated. I think it's more complicated than it seems. I think if you're building a house, like a tiny house on a trailer in a controlled space, that makes a lot of sense. But ultimately, there's still a lot of site work that goes on. You've got foundations. You can't build those in a factory. You could build the whole house in a factory or a controlled space and then move it over to somewhere else. And you still have to hook everything up to it. I think it's going to be a long time before we get there. I'm probably going to be surprised by how much faster it really is than I think it's going to be. But I think at this point, homes are one of the few things that we still build custom in the United States, where most of them are expected to be custom. And if they're prefabricated, it's sort of considered strange, whereas everything else we have is prefabricated, and that's not strange. I think it's going to be more of a matter of small parts being prefabricated, such as, windows have been prefabricated for 100 years, and we don't think twice about that. Nobody builds their own windows anymore. I think it'd be nice, but I think the practicality of it is that we still basically have to build to a site.
I think there's
tension between customizable and cheap. I just know that there are various companies that are doing great stuff. There's Bright Built Homes. There's Benson's, Benson Woods, Unity Homes. And, I don't think, from what I haven't built either of them, but I don't believe that they're any cheaper than site building them. And I think that that's because they do offer customization. I think, unless you say you have 4 plans and you can't mess with them, it's going to be really hard for off-site building to bring the cost down.
There's a lot to be said for that. We actually have panelized a lot of our houses for the last couple of years, and we've done it in a bunch of different ways. Both we had panels that came from Benson Wood that already had the windows installed and the insulation in, and they came and they were ready to throw siding on after you put them together. It takes about a week and a half to put the walls up. And then we, had an air barrier. We could be running heat, and then you still had to do, plumbing and electrical, et cetera, on site. And then we've done other panelization where we basically get an open wall cavity that comes with the self-adhered membrane already on it. They put the panels together, they overlap the membrane, and voila, we have a house. And so I feel like there's got to be somewhere in the middle. And what I love about your zero waste facility and stuff is that there is a lot of construction waste on a site if you don't have a place to put that. Where in Benson Woods factory, if they've got a 2-foot section of 2x4 that's left over after cutting it, they put it in a pile, and then when they need a piece of blocking, they take that 2-foot section and they can use it because they have a place to store it. And there is a lot of stigma about people think mobile home when you say factory prefab panels, which I custom designed a house that somebody just manufactured the wall panels for. So there wasn't anything mobile home about it till it got there. So that's another misconception across the board.
And don't forget about the cost of the factory. There's a tremendous amount of overhead, and I think that affects things pretty. But to go back to Ashley's earlier point, using prefab or factory built is a great way to work more remotely, and especially to work with, say, a builder who maybe isn't totally up on this stuff. So you can get the panelized wall sections with the windows already installed, and suddenly you're bypassing a whole learning curve, but you're showing you're showing the builder how things can be done. So I think if I were to look at doing one of my semi-custom home plans, say 3 hours away, I might seriously look at, I would definitely seriously look at and talk with the folks at Benson Wood and see how we could, work together. And it may not be cheaper, but it might be a better way to introduce somebody to high performance home building.
Well, the other thing I think is important to remember is we spend a lot of time sort of being fascinated by my crew, being fascinated by the aspect of being able to build something indoors and have it be all ready and then bring it to the work site and be done. And then sort of realized that's just, like Bob said, cost of the factory. It's really, once you have a shell, you have an on-site controlled environment. All of our window trim, we build exterior and interior. We build the trim as a unit, and then we put it on the house. And it takes 5 minutes to put it on the house, and it's all the same thing. And the same thing with, saving that 2 foot of 2x4, we do the same thing. And I think it's more about the intent and the efficiency of it than the physical enclosure. So, you know, we always save our scraps. And sometimes we'll actually transport into the next work site because, hey, you know, it's nice to have 20 offcuts of 2x4 kicking around. It's about, our crew tries to keep everything efficient and organized. And, you know, for instance, we started raising trusses with a crane a few years ago, roof trusses. And then we said, well, let's sheathe the outside truss. Well, let's put the gable vent in. Well, actually, let's do the whole trim. The last truss we raised, we literally trimmed the whole thing out and put clapboards on it in the gable end vent. And all that ladder work was done. It was all done on the ground flat. We painted it. I mean, it was, the whole thing went up, painted and all with a crane, and we were done. And so we're eliminating that step of having to get the really long ladder out to do this dangerous high up work. And we didn't do it in the factory. We did it on the ground with the same effect. So I think a lot of it is, you know, taking the factory part out of it and working on the efficiency of it. So that's where I'm coming from.
Yeah, I think there's plenty of room for on site construction, and there will be for the foreseeable future. I spent a year and a half as operations manager at a startup where we were the first North American panelizing company dedicated to passive house construction. So we basically started knowing how to build a passive house, but not knowing how to do panelizing. And we used the Swedish platform framing system, which is pretty similar to Benson Wood. But it was a major investment in equipment and processes to figure out ahead of time, not just what will the house look like, but where is every single piece of material that goes into that envelope. So we would have the entire house fully modeled, cut lists for the entire house. So like, you know, 10,000 piece cut lists, automated equipment, and a staff that was happy to be in out of the rain, but factory workers get paid a little less than on-site workers typically. So there are trade-offs. In the end, the product we put out is as good as any house anywhere. And once the design prep work was done, we could basically frame, insulate, and have the house watertight in about 3 weeks, and have the house ready to be set in about 3 weeks. And then with about a week on site, we could have the house set and dried in. So it's about a month-long process to get a house from concept on a foundation. But so there are places where it makes sense. I mean, I've built windows, I've built doors, I've built cabinets, and I definitely see the advantage of buying ones that have been built in a factory, because just there are huge efficiencies to be made in factory like processes. But there's no reason you can't bring in pieces of that, like Josh says, you know, prefabricate components. You can prefabricate stairs and trim packages, and just to minimize the amount of time you're spending on site, you know, working in the mud.
One of the things that I like too about Benson Wood has their Unity factory, and the people who build the panels then, if it's a Unity home and it's within their target area, are also the people who then go and stand the wall systems that they build. And I think that there's a lot to that in understanding, like, oh, okay, then next time maybe we need to do X, Y, or Z differently to get there. So I agree with what you said, Mike, as you know, there are parts and components and pieces that really just make sense to do. And I think until we have them in closer proximity, I mean, I've had several of my builders say, like, if we had a shop, we would have built X, Y, and Z, and then just brought it to the site and put it up and done that. So I think that there's a conversation around which parts are easier. And you know, we take it for granted and we say, oh, it cuts down on the amount of time that you're on the job site, but it doesn't necessarily cut down the project time, because, you know, you said it's a month in the factory to get it ready to go on the foundation. And so that's still 4 weeks. Now, granted, maybe you could be pouring the foundation during those 4 weeks. And so some on-site, and maybe it'll extend, but we put ours up in January, and even though it only took a week and a half to get the shell up and ready and closed in, it was still January. you know, and then we had an added logistics of, you know, backing a tractor trailer truck down 1,000-foot driveway. And on that site, there actually wasn't a lot of prep space, and I don't know that they could have done a lot of things on the ground in effort of keeping people's interest on a webinar. And this has kept my interest, but for anybody listening to the webinar afterwards, are there any other topics that we want to really hit on as far as economics go?
I think mostly it's just useful for people to see that this is a conversation and that it is a conversation you can have. Again, you know, somebody building a new home or thinking about building a new home, we're just trying to give them more information, more tools, cut through the greenwashing.
More information on prettygoodhouse.org. Follow on the YouTube channel, and we'll add show notes on here to the bottom of the webinar. So thanks for joining us today.